All right, so this is Jacob Kiner doing the Unit 2 mapping demonstration. It is 5/4/2022. Great, so for the first step, for step one, we determine groupings or crossover categories. So this is the data table that was given. See the three pluses are also considered also capital letters, just makes it easy for when you're organizing the data here, and the total here, a number that we'll use later, 5,742. The rest of the respective values are on the chart as well, which we use to determine into groups. So if we look over at the top left, the non-crossover group, it's typically going to be that plus, 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 ABC, but also look at the values, they're going to be the highest values. So the grand total there is going to be 2,702. And then we look at the lowest values to find the DCO, or double crossover group. So the lowest values here, 100, 140, and then the attributing letters and pluses that go with it. I'm going to slide my head over real quick. There we go. And on the right side here, you have the two single crossover groups. Besides looking at the lettering, so you see that top one, for example, AB plus and then plus plus C. Those are going to typically go together because they fill in the gaps that the pluses are. Also look at the values. The values are going to be similar as well. So that 970 and that 1010, and the second one on the bottom, the 420, as well as the letterings match up. Put my head back over here. There we go, which brings us to step 2, determining the gene arrangement. So this is based off the DCO. So if we go back to this real quick, the DCO, the lettering there, A++, plus BC. So we're going to look at the three possibilities. Thankfully, there's only 3 letters, so the combinations are pretty few that we can work with. So the 3 possibilities there, if you're looking the ABC, the ACB, and the BAC. So we're looking for the possibility that lines up with the lettering, like the lettering order that you see the letters, the lettering there. So the A++ is going to be the easiest one to find. So if we look through and start looking at the crossovers, possibility 1, we go from the bottom X up to B over to X. That's obviously not going to work. Same with possibility number 2, get the X to the C to the X, which brings us to the possibility that it has to be, which is in fact possibility 3. If you see again, you got the X, AX, and the BXC. Which brings us back to that A++ and the plus BC. There you go. So possibility 3, which I took the liberty to already rearrange everything to that order. The values themselves don't change, but the lettering is important. I'm going to slide my head over again. If you look at A to C and that B to A, those are going to be, so if you look at the lettering there, you've got the BA plus, so that A to C, and then down there, B++, B to A to C. So those values are important, as you'll see just on the next slide, why the one's B to A and the other one's A to C. So if you go to step 3, determine the distances between genes. So this is going to be a ratio. It's going to be the group total to the overall total. So if you look there, I'll talk about just the NCO one. That's a 270 is that total value for the group total, and then the overall total is that 5742, which gets you 0.47 times it by 100, and you get your percentages, the same thing for each of the other 3 as well. So to calculate that overall total, you've got the B to A to C. So for the B to A, you're going to use the SCO B to A plus the DCO. So that's going to get you 14.3 plus 4.2, get you 18.5 map units. A to C is going to be the same kind of deal, which a grand total 34.5 plus 4.2 is 38.7. So for step 4, calculate the coefficient of coincidence, or C, which is equal to the DCO observed divided by the DCO expected. So if you remember, our DCO value that we observed is 4.2. Got to bring it back to decimal, so 0.042. The expected DCO If you look back at the values for the map units, you just bring those back to decimals by dividing by 100, and then you multiply them. So 0.185 times 0.387, which brings you to 0.0716. So the C is equal to the observed divided by the expected, which gives us the value 0.587. And that value is important to our last step here, calculating interference. Interference is equal to 1 minus C, that coefficient of coincidence. So we get 1 minus 0.587, which gets us 0.413. And then we multiply that to get a percentage for our conclusion. So our conclusion here is that it is a positive interference because the C value was less than 1, which gives us 41.3% less DCO than was originally expected. And that concludes my video.